So as a reminder, 6.6 is based on the zero product rule. So what the zero product rule says, if we have things that are multiplied together and we know that the answer is zero, then the only way that can occur is if one of those pieces is equal to zero. If neither number is zero, you can't multiply two positive numbers together and get zero, or you can't multiply two negative numbers and get zero, and you can't multiply a positive times a negative and get zero. Adding, yes, but multiplying, no. The only way you can multiply two numbers and the answer is zero is if one of those numbers is zero. So that in order to utilize this, we must have a zero on one side and the other side must be a product. So the other side has to be in factored form. So notice the problem that we're given. We have a factored form on the left and a zero on the other side. So this is one application of factors. So if this equals zero, then zero times whatever the other parenthesis is would be zero. Or if this one is zero, no matter what the first parenthesis comes out to be, if the second parenthesis equals zero, that would be zero. So we're going to ask ourselves, how can we make that first parenthesis equal zero? Also, how can we make the second parenthesis equal zero? So both of those we just solved. To get x by itself, the opposite of subtracting 9 is to add 9 to both sides. So those cancel, and we get x equals 9. On the other side, the opposite of minus 6 is to plus 6. We do that on both sides, so those cancel, and we get x equals 6. So each of those are going to be solutions to our equation. If we were to check, yes, I copied it right. So if we were to check, if we try x equals 9, if we put a 9 everywhere we have an x, then notice 9 minus 9 is 0. 9 minus 6 is 3, and it is true that 0 times 3 is 0. Likewise, if we do the 6, if we put a 6 in everywhere we have an x, 6 minus 9 is negative 3. 6 minus 6 is 0, and negative 3 times 0 is also 0. So yes, each of those numbers, when we plug them in for x, makes this equation a true statement. So on all of these problems, we want to have a 0 on one side, a product on the other side. So here we have a product on the left. We have x times that parenthesis. And then we have a 0 on the other side. So we want to find out how can we make that equal to 0 and how can we make that equal to 0. So we take the first factor, set it equal to 0, the second factor, set it equal to 0. On the first one, there's nothing left to do to get x by itself. So 0 is one answer. On the other one, we can subtract 6 from both sides so that those cancel. And our other solution is minus 6, negative 6. If you were to check, if you were to plug in a 0 or a negative 6 everywhere you have an x, both of those would make that a true statement. Now in this one we have a 0 on one side, but we don't have a product on the other side. So we can write this as a product. We can factor the left side. Before we factor, we always want to make sure one side is 0. So we do have that. The other side, we factor x squared is x times x. And this tells us our signs have to match. And the middle one tells us we have to have two negatives. and then we're looking for what numbers multiply to make 40 and add to make 13. So there's 1 times 40, that's not going to make 13. 2 times 20, that doesn't. 4 times 10, that doesn't. But 5 times 8 does make 13 also. So 5 there and 8 there. So notice it is important that we are familiar with our factoring. Once we have a product on the one side, we say what makes the first factor equal to 0 and what makes the second factor equal to 0. So get x by itself. So one answer would be 5. Get x by itself. So the other answer would be x equals 8. Just for practice, let's check one of those. So our original problem is x squared minus 13x plus 40 equals 0. Let's see if 5 really is a solution. So normally when I plug numbers into a formula, I like to put a parenthesis around what I'm plugging in. That's a good practice. So everywhere we have an x, we're going to put a 5 and we're going to put a parenthesis around it. 5 to the second, 5 times 5 is 25. 13 times 5 is 65. And then you can just go left to right. 25 minus 65 is negative 40. Negative 40 plus 40 is 0. That's true. That means when we plug a 5 in for x, that works. That's a true statement. So that's the solution. And if we were to check an 8, the same thing would be true. We would get a true statement. Now, let's go back and do one like this. This is already factored for us. We have a 0 on the other side. I just wanted to illustrate that sometimes I'll have people that once it's factored, they'll just say, well, the answer is going to be the opposite of this. So positive 5 and the opposite of that, so positive 8. And that does work a lot of times. But if we just said, well, the answer is the opposite of negative 9, that's not going to work here. We're looking for what makes 7x minus 9 equals 0, and what makes 5x plus 4 equals 0. So we have to get x completely by itself. So remember the way we do that, we get the variable part by itself first. So add 9 to both sides. That gives us the 7x by itself. And then to get the x by itself, the opposite of multiplying is to divide. So x is 9 over 7. On the other one, we want to get 5x completely by itself. So take the 4 to the other side. So 4 minus 4 is 0, so we're left with 5x on the left, negative 4 on the right. And again, the opposite of multiplying is to divide. So those 5's cancel, so negative 4/5. So just be careful that you don't just say, oh, it's just the opposite. Yes, that's true sometimes, but it's technically what makes that equal to 0, what makes that equal to 0. Again, the reason for that is because 0 times anything equals 0. So we're trying to find out how can we make that 0 so that our product makes 0, and how can we make that 0. Okay, this one has a 0 on one side, so that's good. We need the other side factored. We only have 2 terms, but remember the very first thing we look for. We don't look for, is it a difference of squares or a difference of cubes first. We always look for a common factor before we do more sophisticated things. Both terms have an x in common. So if we pull an x out of the first term, we're left with an x. If we pull an x out of the second term, we're left with an 8. So we have 2 factors, set each factor equal to 0. The first one has x by itself. The second one, if you add 8 to both sides, then you have x by itself. Okay, this one is neither factored or have 0 on one side. So we want one side to have 0. It really doesn't matter which side. Um, the left or the right side only has one term, so let's get rid of it on the right side. So to get rid of a 24, we take 24 away, and we have to keep it balanced, so do the same thing on both sides. So 24 minus 24 cancels, making 0. On the other side, none of those are like terms, so we just put them in descending order. X to the second, x to the first, and then no x's. So now we have a 0 on one side. So we need to get the other side to be a product. So x squared is x times x. Since this last sign is negative, then our last numbers have to multiply to make a minus, so that's a positive times a negative. And then what numbers multiply to make 24? Since we have different signs, we need a difference of 5. So 1 times 24, that doesn't have a difference of 5. 2 times 12, that doesn't. 3 times 8, hey, that does. Those have a difference of 5. We need our middle term to be negative, so we need to have more negatives. So our bigger number needs to be the negative one. And if you're not sure about that, you can FOIL this out, multiply this out, and reassure yourself that this is the right way to factor that. Once it's factored, and we have a 0 on the other side, set each factor equal to 0. How does this make 0, and how does that make 0? So subtract 3 from both sides here, and we get one solution. Add 8 to both sides here, and we get the other solution. So 0 product rule. Have to have a 0 on one side, have to have a product on the other. Okay, this one is a little bit different as well. We have a product on one side, but we don't have a 0 on the other side. We have to have both. We have to have a product and a 0. So to get a 0 on the right side, we could take 10 away from both sides. 10 minus 10 is 0. And let's just copy down what we have on the other side. We have x minus 1 times x plus 2, and then we have minus 10. Now, order of operation says that before we subtract 10, we would have to multiply those parentheses together. We can't just simply take 10 away from either one of those parentheses. That doesn't work. That violates our order of operation. Also, now notice that the left side is not actually in a factored form. If we have a plus or a minus on the outside of our parentheses or between things that are on the outside of the parentheses, this is not considered to be factored. Even though there is a product, the whole thing is not a product. So this is not factored. So what we have to do is we have to combine all of these terms. So to combine that minus 10, we do have to multiply that together first. So x times x is x squared. X times 2 is 2x. And then distribute the negative 1. Negative 1 times x is minus 1x. Negative 1 times 2 is negative 2. And then bring down the minus 10. So this came from distributing the parentheses, and then we brought our minus 10 down. Now combine like terms. You only have one x squared term. These are both x's, so 2 minus 1 is 1x. And then these are alike. Minus 2 minus 10 is negative 12. So we have combined the left, but it's still not factored. So we need it factored. So x squared is x times x. This tells us our signs have to be opposites, because negative times positive makes a negative. And we need numbers that multiply to make negative 12 and combine to make that 1. Numbers that have a difference of 1. So that's, of course, going to be 3 times 4. We have a positive in the middle, so our bigger number needs to be the positive one. So that's how that would factor. So we have a product on one side, a 0 on the other. So now we can use our 0 product rule. How do we make x minus 3 0? And how do we make x plus 4 0? So the first one, add 3 to both sides, and we get that x can be 3. The other one, take away 4 from both sides, and we get that x can be negative 4. Now, since this problem was so different, let's check it to see if that really does work. And again, we don't have to check both of them for time's sake. It would be a good practice to do. But let's see, let's check the negative 4. Let's see if negative 4 is a solution here. So everywhere we have an x, we're going to put a negative 4. So in the first parentheses, negative 4 minus 1, those are the same sign, so we add the numbers, take the sign of the bigger. In the second parentheses, those signs are different, so we subtract the numbers, take the sign of the bigger. A negative times a negative makes a positive. 5 times 2 is 10, and that's what we had on the other side. So that means when we put a negative 4 in for x, that's a true statement, so that's an answer. So that's good.